It's a common misconception that the asteroid belt is littered with asteroids. People will often ask how a spaceship, like Dawn, could navigate such a crowded area. This activity, scaling the asteroid belt, helps correct those perceptions and puts the scale of the asteroid belt into perspective. There are many points to illustrate with this model of Earth, Moon, and the asteroids. I'll show you a few, and you can find more in the manual. We'll start with the model of the Earth and the Moon. If we could shrink the Earth down to this size, 1 meter, ask your audience to guess how big they think the Moon would be on this scale. Get them involved by asking them to use their hands to show you the size. Then, bring out this image of the Moon and show them that you could line up almost 4 moons across the Earth. Then, the distance question. If you tell them that it's 400,000 kilometers between the Earth and the Moon, it's likely they'll not remember or care. By telling them that you could fit 30 Earths between the Earth and the Moon, you give them a distance that they can relate to. Even better, ask an audience member to pace out 30 giant steps holding the Moon image. It's also an opportunity to talk about the near and the far side of the Moon. Continue the scaling activity with those model asteroids we made earlier. Let them know that the Dawn spacecraft is touring the asteroid belt. Then ask how many of your audience members think the spacecraft will have to carefully navigate to avoid crashing into all those other asteroids on the way. Most people have the misconception that the asteroid belt is tightly packed with asteroids, like in these pictures. Here's one way to clear that up. Show them this model of Ceres, one of the asteroids Dawn is visiting. This model is on the same scale as this Earth. Ceres is the biggest asteroid in the whole asteroid belt, and it's about the size of Texas. If Ceres is the biggest on this scale, ask how big of a ball your visitors think all the asteroids would make. It turns out there's not very much material at all in the asteroid belt. These are the 4 biggest asteroids, and they make up half of all the mass in the asteroid belt. On this scale, all of the asteroids, including these 4, would fit into my hands. Look how small that is, compared to the Moon, say. There's not much material in the asteroid belt, and in fact, it's so spread out that the average distance between 2 asteroids is over 1 million kilometers. Oh, right. Give them a way to understand that distance. You can hand 2 of the small asteroids to 2 visitors and tell them that at this scale, they'd have to stand about a football field apart. The surprising thing about the asteroid belt is that if you could stand on an asteroid, chances are you wouldn't even see another asteroid in any direction. They're too small and too far away from each other. Now ask your visitors if they still think the Dawn mission will have to dodge asteroids. It turns out that Dawn must plan very carefully to encounter 2 of the largest asteroids, Vesta and Ceres. Dawn is unlikely to see any others along the way. Let me quickly give you another example of how to use these models. All of these red dots on the banner represent the locations of impact craters on Earth. In fact, we've found over 170 craters made by asteroids and comet impacts. Your audience will likely recognize one of the very largest craters on Earth, Chicxulub, here in the Yucatan Peninsula. It's the site of the devastating impact that spelled disaster for the dinosaurs. On this same scale, ask your visitors to show you the size of the asteroid they think that caused the devastation on Earth. I bet they won't guess that it was only about 10 kilometers across. That means that on this scale, the asteroid that hit was the size of a tiny piece of sand. Yikes.